This video is brought to you by mywayteaching.com.
In this particular part, let us solve few problems. So the first problem is a structural steel rod has a radius of 10 mm and a length of 1 meter. 100 kilonewton force stretches it along its length. Calculate the stress, the elongation and the strain on the rod. And Young's modulus of structural steel is given by 2 into 10 raised to 11 Newton per meter square. So let us find the solution for this. So we assume that the rod is held by a clamp at one end and the force F is applied at the other end, which is parallel to the length of the rod. So stress is given by, yes, stress is given by force by area. So we know area is given by pi r square, isn't it? So here they have given a force of 100 kilonewton, radius of 10 mm, that is given by 10 into 10 raised to minus 3 meter. So if you substitute that 100 kilonewton, that is the force, the value of pi is 3.14 and r is 10 raised to minus 2 the whole square. So if you solve this becomes 10 raised to 5 and this is 3.14, 10 raised to minus 4. We'll get it as 3.18 into 10 raised to 8 Newton per meter square. Okay, so coming to the second, that is elongation. Which is given by delta L. So we know Young's modulus is equal to, what is Young's modulus? The ratio of, yes, tensile stress to the longitudinal strain. So we can write it as F cross L divided by A cross delta L. Here we want delta L. So taking delta L outside, we get it as F. We can write it as F by A into L by Y. Okay, and here we know F by A, that is stress, which is given by 3.18 into 10 raised to 8, isn't it? Newton per meter square, and the length is 1 meter and the value of Young's modulus is given in the question, that is 2 into 10 raised to 11. So if you simplify this, we'll get it as 1.59 mm into 10 raised to minus 3 meter. In other words, we can write it as 1.59 mm. Okay. So now moving to the third part of the question, they are asking us to find out strain. So strain is change in length to the original length. So delta L is 1.59 into 10 raised to minus 3, and the original length is how much? Yes, it is 1 meter. So strain is given by 1.59 into 10 raised to minus 3. Okay, that is given by 0.16%. If you convert it in terms of percentage, that is 1.59 into 10 raised to minus 3 multiplied with 100. It gives this much of percentage. Okay. So this is the first problem where we found the stress, elongation and the strain given Young's modulus. So now let us move to the next problem. A copper wire of length 2.2 meter and a steel wire of length 1.6 meter, both of diameter 3 mm, are connected end to end. When stretched by a load, the net elongation is found to be 0.70 mm. Obtain the load applied. So here they are asking us to find out the load applied. Okay, let us see what is the solution for this problem. Here a copper wire and a steel wire, both are of diameter 3 mm. They are connected end to end. When stretched by a load, the net elongation is 7.70 mm. So we should find the load applied. Means the force applied, in other words, isn't it? Yes. See, the copper and steel wires are under a tensile stress because they have the same tension equal to the load W and same area of cross section A. So we know stress is equal to strain into Young's modulus, isn't it? Stress is equal to the ratio of stress by strain is nothing but the modulus. Since this is a in case of longitudinal stress, we'll call it as Young's modulus. So we can write stress, that is W by A, the restoring force per unit area. Strain is delta L C by LC. So the same is applicable to the, yes, steel wire also, not only copper wire, because both are subjected to the same load, isn't it? So from this we can write delta LC by LC is equal to YS by YC multiplied with delta LS by LS. Okay, delta and we can write it as delta LC by delta LS is equal to YS by YC multiplied with, so we can write it as LC by LS. So here they have given the length of copper as 2.2 meter and the length of the steel wire 1.6 meter, isn't it? And we know from the table we studied the Young's modulus of this copper is 1.1 into 10 raised to 11 Newton per meter square, and the Young's modulus of steel is given by 2 into 10 raised to 11 Newton per meter square. Okay, so now we should substitute the values. Y's is 2 into 10 raised to 11. YC is 1.1 into 10 raised to 11. LC is 2.2 and LS is 1.6. So here, if you simplify this, we'll get the value 2.5. In the question, they have given that the total elongation is given by delta LC plus delta LS. The value is given as 0. Yes, 7 mm, isn't it? So that is 7 into 10 raised to minus 4 meter. So using these two, one is this equation and the another one is delta LC by delta LS is equal to 2.5. If you take delta LC is equal to 2.5 delta LS, and if you substitute this in the first equation, we get the value of delta S, that is equal to 2 into 10 raised to minus 4 meter, and delta LC is given by 5 into 10 raised to minus 4 meter. Okay, so now W is given by A into YC into delta LC by LC. We know the values here, so you just substitute A is equal to pi r square, where r is given by 1.5 into 10 raised to minus 3, and YC delta LC is given by YC is given by 1.1 into 10 raised to 11, and delta LC is given by 5 into 10 raised to minus 4, isn't it? And the LC is nothing but 2.2. So if you simplify this further, So we'll get the value of W, that is equal to 1.8 into 10 raised to 2 Newton. So what is this W? Yes, this is nothing but the load applied, or in other words, we can say this is the force that is applied. The unit of this is obviously, that is the unit of force, which is given by Newton.